Okay, g'day all and welcome to another tute. I can't believe I've kept this up for more than a week. I said I was going to make daily tutes, I was lying through my teeth. Anyway, it's turning out okay so far. What I want to talk about today is a little bit more of define, so it's actually slightly more flexible than it's mostly used for. Good English. Define has a few tricks up its sleeve is what I'm trying to say, and we're going to look at a few today. We'll have a quick look at some pitfalls which are pretty much irrelevant, but I was talking to my brother about define. He's not a programmer, he's a drum builder, but I was talking to him about define, and the first thing he said was one of these pitfalls, and I had to scratch my head. I had no idea about the answer to his question, but we'll have a look at that quickly, and then we're going to look at the Stringizing operator, the Stringizing operator. It's a ridiculous word, but I didn't make it up, seriously. I make up cooler words than that. And we're also going to look at the concatenating operator for define, so hopefully it's going to be good fun. The first thing, this is just a bit of fun. Most people probably, won't find this fun, me included, but you might, so I'll tell you. You can basically redefine C++ language if you want. Yeah, have a look at this. This is pretty nuts. So you can use a bunch of defines together to completely rewrite the language. So this blue code down here is syntactically correct C++ code if you use all of these weird defines. It's not often a good idea, but it's good to know that if you don't like the way that syntax is in C++, you can make your own. I find, particularly with complicated APIs, something like maybe DirectX or your OpenGL and these graphics APIs, the syntax is often really tricky. So you might want to define a simpler syntax for yourself while you're learning. But you will eventually probably get used to the syntax of the API that you're using if you use it for long enough. So that's just an idea. Okay. Alright, the first pitfall. This is what my brother said. Can you define? And I had no idea, so I tried it out. But it turns out that you can't. If you try and redefine define as something, it just won't compile. Yeah, so the answer is no. Don't define infinite loops either. Yeah, so if you define, just for an example, if you define a product in terms of division and then you define divide in terms of a product, well, yeah, it's not going to compile. You would, in theory, just end up with this really weird-looking infinite loop of braces and horrible things, but the preprocessor is just going to say, nah, neither of them are defined, and I don't know what you're talking about. Just rewrite it, bro. Yeah, don't define infinite loops. Okay, but on to the crux of the tute today. So I want to talk about the Stringizing operator and the concatenation operator. The first one is called the Stringizing operator. So when you use the pound symbol, or the crosshatch I call it, in a replacement string for define, what it means is the Stringizing operator. And the preprocessor turns the token's name into a double quoted literal string, so you can pin it to the screen. And this is pretty useful for debugging, as we'll see in a minute. So here's just an example. We've got define varname x. So it's just a macro, it takes one parameter x. And the replacement string is just the hash and then x. But what happens is if we say something like cout the token is varname QWERTY, we pass it a variable that we've got, like QWERTY, it's going to literally print out that name, QWERTY, Q-W-E-R-T-Y. And it doesn't even matter if this x parameter isn't actually a variable. The preprocessor doesn't care, it's just going to turn it into a string and print it to the screen. So we can print out QWERTY and hello like that. Where normally, it's pretty difficult to get C++ to print out a variable's name. What do we got down here? It doesn't matter if the... Yeah, I said that already. Okay, so that's called stringizing. I don't know why. They just felt the need to make up a new word. It's a good word. Okay, so this is where it's useful. It's useful in evaluating variables for debugging purposes. So the following example shows that. We've got define eval var, so evaluate a variable in other words, and it takes a single parameter. And all that it does is cout some information on that parameter. So cout the type ID as a string, that's the type ID x.name. Then I have a little space, and then I cout the name of the actual parameter using the Stringizing operator that we just looked at, and then I cout the value of the parameter. So something like this, eval var a, when a is an integer with 19, is going to print to the screen the string, or it's going to see out the string int a equals 19. Yeah, so eval var b, when b is a double with 27.3, is going to print to the screen or see out double b equals 27.3. So that's unusual to be able to print out that sort of thing with see out. Usually you can't do that, but you know, thanks to define and the stringizing operator, we can do exactly that. Okay, the next trick, the next operator for define is called the concatenation operator, and this is two hashes beside each other. What it does is joins arguments together with no spaces. Yeah, so it's a little bit weird, but that's what it does. So something like define join AB as A hash hash B, and then what we can do is say yeah, my and var as separate values, and yeah, evaluate the variable my var. So the define's actually going to join those two macro parameters together, my var, without spaces, and it's going to come up with my var. So by the time the compiler actually sees this line, all it's going to see is see out the value is, and then my var. Yeah, good stuff. Okay, so concatenation might be useful as well. Alright, but on to some challenges. So I might just close that down and bring up old Visual Studio. I'll put it on the side here, and I'll put this over here. Here's a few challenges. So have a go at this if you want. The answers are basically on the previous slide, so if you want to just rewind, you'll probably get the answers. Okay, so make a define called varName, which takes a parameter and returns its name as a string. Okay, so that's pretty easy. That's just the stringizing operator. So let's have a go. Define varName takes a single parameter. I'll just call it x, and it returns x. Just like that. Let's just test it out, shall we? See out. The variable's name is varName, my var. Okay, I'll just test it out. So my var doesn't even exist, but it doesn't happen to matter. There you go, the variable's name is my var. Doesn't happen to matter in this particular instance. So that's the first question. And the second question, make a define macro called sameType that takes two parameters and determines if they are the same type, returning true if they are and false if they're not. Okay, well I did get excited with these questions. How in the world do we do that? Okay, so we need type ID. Let's just define sameType x, y, and what's it going to do? Well, it's going to type ID x dot name equals type ID y dot name. Yeah, it's going to do that. Okay, so type ID dot name is going to return the data type of this parameter, whatever it is, and type ID y is going to return the data type of the y parameter. So in this instance, we are actually going to need to actually set up variables. So I might say int j equals 20 and int y equals 290. Why not? And let's see if it works out. So cout, are they the same? And we'll call that macro. So same type j and y and all. Now they are the same type. They're both integers. So hopefully, with a bit of luck, that'll return 1. Yeah, it does. Are they the same? 1. Or yes, in other words. If we change one of them to maybe a float, so float y is 290. So now they're not the same type. We should get 0. Let's have a look. Yeah, there you go. Are they the same? No. No, they're not. Or you could do, if you wanted, same type, if same type, and then j and y, see out they are the same. Yeah, so that might be useful. It's useful often, well sometimes, to check if two variables are exactly the same data type, and you can use this yeah, same type macro to do that. Alright, question number 3. This is even this is even more excitable. Create 5 integer variables called a0 to a4. Okay, int a0 A1, A2, A3, and A4. Make a define called pick, which takes two parameters, n and idx. Okay. What am I typing? Define and pick. It takes a what? It takes n and idx. I was awful specific about the names there. I wonder what I was thinking. Anyway, it joins them both together to reference an a variable. Okay, so that's just going to be n, that thing, the concatenation operator, idx, use pick to set a3 to 25. Okay, I might just put this in brackets. And let's see if we can use pick. A is the first bit, and 3 equals 25. See if we can do that. See out the value is A3. Let's see if we successfully set A3 to 25 using our concatenation operator. Yeah, there we go, we did, it worked, so that's pretty good. What we could also do down here, instead of printing A3, we could actually use our pick operator again. So let's just pick and A and 3. This is going to be unreal. 25 it's going to say. Yeah, there you go. Good stuff. We might be able to, I'm not sure, but we might be able to leave that blank. Let's have a go. Yeah, there you go. So you can actually leave the first parameter blank. So the concatenation operator is perfectly happy to add nothing or blank to A3. Anyway, that's just a bit about the stringizing operator for define and the concatenation operator for define. And next tute, I think we'll look at a really cool trick called X macros. Thanks for watching all. See you later.